Hello, welcome back to my channel. Today I'll be going over wave calculations on how to read and solve various wave and energy calculations. So as you can see here, the equations are provided for you, as well as the two constants. Now what you will be responsible for is knowing what each variable stands for and what they measure in. So we have lambda, or what I like to call upside down y. That is wavelength, and it is measured in meters. So basically, if you read a problem that says like this in meters, you know that is wavelength. And then you have f, which is frequency, and the units for that is hertz, or Hz. And then we have energy, which is obviously E, and it's measured in joules, capital J. Alright, so we'll do number one, and then we're going to solve that together. The wavelength of a green light from a traffic signal is 5.2 times 10 to the power of -5. Calculate the frequency. So I would break down the question so it's like less intimidating, and all you have to do, so the hard part is just to figure out what is what and which equation to use, and once you know that, then the rest is pretty simple. So first we are given this number here, 5.2 times 10 to the power of -5, and since it's measured in meters, that is my wavelength. So I'm just writing down what I know. And that's all I know basically. And then it's asking for the frequency. So my frequency, or my F, is question mark. And then based on what I have here, I'm going to figure out based on my options here which equation to use. So the equation that has y and f in it is this first question, this first equation here, C equals YF. Now keep in mind, C, the speed of light, is this one here. It is always a constant. Even though it's not written in the question, you are always given it. You always use C. So I'm just going to add that here for the sake of the work that we're going to do. And now we just solve. Now we have our two knowns and our one unknown. Call it, the x value. And now we're going to substitute everything in. Like so. And from there it's just basic algebra. How do we get f by itself? We divide by 5.2, power -5 on both sides. So when we divide 3 times 10 to the power 8 divided by 5.2 times 10 to the power -5, that should be my answer. And remember to do the E button. So 3E 8 divided by 5.2 E -5 equals. So this should be answer, and I'm going to round to 2 decimal places, so 5.77 times 10 to the power of 12. And the units for that is hertz, and that is my final answer for frequency. Okay, so for number 2, this time it's pretty much asking for the same thing, but different numbers. So actually, based on using the numbers here, the work process here, try this by yourself and pause the video and then unpause to check your work. Alright, so this is what you should have gotten for frequency. So again, you always have the speed of light, and when you substitute that in, the wavelength as 4.25 times 10 to the power -9, you divide both sides, you should get 7.06 times 10 to the power of 16. Alright, so I'm going to skip over to number 5, because you will be using a different equation here. What is the energy of a photon of visible light that has a frequency of, let's change that to 1 times 10 to the power 15. That's easier. Okay, so we are given the frequency, F equals 1 times 10 to the power 15. And we are trying to find energy. Question mark. So based on our formulas, which formula do we use that has E and F in it? It would be this one, E equals HF. Alright, and then again H, that is a constant, even though it's not in the question, we are always given it, 6.626 times 10 to the power negative 34. And now we're going to plug that into the equation. So E equals my H times my F. And that's it. And this is actually a lot easier because all you have to do is multiply across. So when I do that, I should get 6.626 times 10 to the power negative 19. And it is measured in joules. Alright, so number 6 now. What is the frequency in hertz of a photon whose energy is that number? So this number here, 9.28 times 10 to the power of negative 15. That is my E. And I am trying to find frequency. And I also have my H, as always. And based on the formulas, we're going to use E equals HF. And we're going to plug this in. And now to get F by itself, again, algebra from here, you divide on both sides. So when I do that, I should get 1.4 times 10 to the power of 19. It's measured in hertz. Alright, so basically we did one of this, and I'm going to show you how to do a problem with energy and wavelength. So I think there's a problem in the back here that we can try. Let's do number 10. Now I'm reading the questions here. What is the wavelength of a wave that gives off 5.6 times 10 to the power negative 23 joules of energy? So this number here says joules of energy, so that is my E. E equals 5.26 times 10 to the power negative 23. And it's asking for wavelength, so that's my Y. And based on the equation here, we have E equals HC divided by Y. So whenever you have wavelength and energy, so E and Y, it's always this equation. All right, and again, the H and the C are both constants. I'm just writing it down to prevent flipping back and forth. So C is 3 times 10 to the power 8. Now we have everything that we need, and we plug it all in. 5.26 times 10 to the power negative 23 equals my H, my C, Then my y, or my wavelength, that is my unknown. This is my x. Alright, so this is where it probably gets a little tricky because my unknown is in the denominator, and if you know your algebra, you like cross multiply and divide. Now my trick is, what's easier is that since this number is like over 1, right, all you have to do to get y equals, you just switch these two. So the y goes up here, this number goes down here. So I'm just going to rewrite it. So y equals 6.626 times 10 to the negative 34 times 3 times to the power 8 divided by this number here. You plug that into the calculator. That should be your final answer. .78, let me round, 3.78 times 10 to the power of negative 3, and measured in meters. There you go. So let's do one more using the same equation, and you're going to try this by yourself. Number 12, what is the wavelength if you have 2.23 times 10 to the power negative 18 joules of energy? Again, pause the video, try it by yourself, and then play to check your work. Alright, this should be your answer. 8.91 times 10 to the power negative 8 meters. So again, I substitute everything in, and I just switch these y equals, and then this number goes down here in the denominator. I plug it in, and this should be my final answer. Alright, so I hope this helped. We just did one of each type of formula. We used all the constants. So I hope this helps. And thank you for subscribing, and thanks for watching. Have a great day.